So like momentum conservation problems, energy conservation problems take a before and after picture, and then we equate the energy before to the energy after to find what it is we're interested in. So let's look at this problem. A 10 kilogram runaway grocery cart runs into a spring, which is really commonly found in parking lots, with a spring constant of 250 newtons per meter and compresses it by 60 centimeters. We want to know what the speed of the cart was just before it hit the spring. So we're going to take the same approach as before, or as always, take a before and after picture of what's going on. So before, let's imagine that the cart was originally moving to the right, so there's a wall here. There's a spring which is not compressed, and we have our shopping cart with really big wheels and a handle, and so it's moving to the right with some initial speed. And the after picture is that now the spring is compressed some amount. So here's my shopping cart with the really big wheels. And the shopping cart has compressed the spring some distance x from where it would have liked to be. So let's just list some of the things we know and what we want to find. So we know the mass of the shopping cart, 10 kilograms. We know the spring constant of the spring, 250 newtons per meter. And we know the compression of the spring, 60 centimeters or 0.60 meters. We also know that the final speed of the cart is actually 0 because the cart is compressing the spring by its maximum compression, and so that's just the point at which the cart has stopped. And what we want to find is the initial speed of the cart, VI. So before we go in and trying to solve this, I think it's useful to identify the types of energy that are in our system to begin with. So the type of energy we have to start with is just kinetic energy, and the type of energy we have to end with is just spring potential energy. We don't have any spring potential energy to begin with because the spring is not compressed, and we don't have any kinetic energy to end with because the cart is not moving. So now let's go to our solve stage, and we're going to use the conservation of energy to solve. Use conservation of energy. Let's write out our energies in a bit more explicit detail. So the initial energy, which was Ki, 1/2 the mass of the cart times the initial velocity of the cart squared. And the final velocity, the final energy is the spring potential energy, and that takes the form 1/2 K x squared. So conservation of energy tells us that the initial energy is equal to the final energy. So we can set 1/2 m VI squared equal to 1/2 K x squared, and we can solve for what we're after, the initial speed. Notice that these 1/2s actually cancel, and after doing a little bit of algebra, we find that VI is then Kx squared over m, and actually the square root of this whole thing. And plugging in the numbers, we get something that looks like 3 meters per second, or around 6 miles per hour, and that's not too unreasonable for a shopping cart.